check. Check. Yeah. Check. கேக்குது நல்லா கேக்குது. Okay. Hello everyone. Hello people. Hi everyone. So இப்போ இன்னிலிருந்து April 2nd உங்கள் நீட் எக்ஸாம் இஸ் ஆன் May 3rd. இன்னிலிருந்து கரெக்டாக 31 days இருக்கு. ஓகே 31 days தான் இருக்கு. ஸோ டைம் வேஸ்ட் பண்ணாமல் கொஞ்சம் ஃபோக்கஸ்டாக இன்னும் படிக்க வேண்டிய டைம் ஆயிடுச்சு. படிக்கிறதை விட ப்ராக்டிஸிங் கொஷின்ஸ். ஓகே ஆல்ரைட். ஓகே ஆஸ் யூஷுவல் செஷன் ஸ்டார்டிங்கில் ask me your NEET related queries. So last 30 days I'll help you with whatever I did present from 11th standard. Hello gummy bear and Naresh Kumar. Hi Naresh. As usual, our class starts with something similar to this every time. Okay, consider me as your senior, a brother or a mentor, whatever. Okay, you know, if you have any doubts regarding your preparation, எப்படி பண்ணனும், if you're stuck somewhere, you know, just ask me. I'll help you out. Okay. Hi. Safe score சொல்ல முடியாது. It's unpredictable. Okay, we can't predict stuff. Okay, it will be easier than NEET 2025. I can tell you that. ஓரளவுக்கு. பட் சேஃப் ஸ்கோர்னா இப்போ நாங்கள் 2024 நீட் படிக்கும்போது we were like 600+ கிடைச்சா போதும்னு சீட் கன்ஃபார்ம் அப்படின்னு நினச்சிட்டு இருந்தாங்க நிறைய பேர். ஆனால் 613 வாங்கி என் ஃப்ரெண்டுக்கெல்லாம் கிடைக்காம போயிடுச்சு. எனக்கு தெரிஞ்சவங்களுக்கெல்லாம் 613 கிடைச்சும் they had to repeat one more year. Okay, so I can't assure you this எவ்வளோ மார்க் எடுத்தால் சேஃப்னு. Okay, it all depends upon how other people have wrote the exam. Yep. And how they found it easy or difficult. Okay, so physics இப்போ பார்த்தீங்கன்னா whatever you're doing, okay, if you haven't prepared olunga till now, okay, but still you're going to write the examination in next month, third or next month third there. Okay, what you're supposed to do now, there are certain high weightage chapters. If someone asks about that now, I'll go in a bit detailed, okay. நிறைய பேர் கேட்டாங்க ஹெவி வெயிட்டேஜ் சாப்டர்னா இதெல்லாம் ப்ரோ இதெல்லாம் படிக்கணும் அப்படின்னு. ஐ லெட் யூ நோ, ஓகே. டிஸ்ட்ராக்ட் ஆகுறான்னா கொஞ்சம் என்ன பண்ணணும்னு தெரியல, ஆனால் அவுட் ஆஃப் கண்ட்ரோல் போய் அப்பப்போ டிஸ்ட்ராக்ட் ஆகுறேன். ஓகே, ஆல்ரைட். This is very common amongst யாரெல்லாம் any everyone at this point, okay. எல்லாருமே டிஸ்ட்ராக்ட் ஆகிறாங்க. பட் யூ ஹேவ் an exam next month, okay. இப்போ வந்து ஆஃப்டர் எக்ஸாமினேஷன் நீங்கள் ஏதாவது வேலை பண்ணுறீங்க, அப்போது சின்ன சின்ன வேலை யூ ஆர் கெட்டிங் டிஸ்ட்ராக்டட்னா இட்ஸ் ஸ்டில் பேட், ஆனால் பட் நாட் ஆஸ் பேட் ஆஸ் இட் இஸ் நவ், ஓகே. ட்ரை டு அண்டர்ஸ்டாண்ட் தட். நீங்கள் இப்போது பண்ணுற விஷயம், ஓகே, யூ ஷுடன்ட் ரிக்ரெட் இன் த அப்கமிங் ஃப்யூச்சர் ஆஃப்டர் அ மந்த், ஓகே. ஒரு மாதம் கழித்து நான் முன்னாடியே ஒழுங்காக படிச்சிருந்தா, ரைட், ஒழுங்காக படிச்சிருந்தா ஐ வுட் ஹவ் காட்டன் சீட் சம்வேர், அந்த மாதிரி ஒரு தாட் உங்கள் மைண்டில் வரக்கூடாது, ஓகே. மேக் ஷுர் தட் டசன்ட் ஹேப்பன். அண்ட் தட்ஸ் தி ஒன்லி திங் தட் ட்ரோவ் மீ த்ரூ அவுட் மை 12th ஸ்டாண்டர்ட். நான் வந்து ஐ டென்ட் வாண்ட் மை செல்ஃப் இன் த ஃபியூச்சர் டு ரிக்ரெட் வாட் எவர் ஐ வாஸ் டூயிங் தென். ஸோ யா, ஆனால் இன்னொரு கிராஷ் கோர்ஸ் வருதா? This is the only crash course இப்போதைக்கு. If it were, I'll let you know. Almost all the chapters I have started now, but I can't complete any chapters completely. இதில் is it very specifically in physics, chemistry or biology, இல்லை என்ன சப்ஜெக்டில் வந்து you are not able to complete it entirely? எனக்கும் ஐ ஹேட் திஸ் ஹேபிட், ஓகே. whenever I study last 5 pages I skip it. அதுலேருந்து நிறைய கொஷின் கேட்பாங்க. அதுக்கப்புறம் when then later on I realized that அந்த கடைசி 5 பேஜும் வந்து இம்பார்ட்டன்ட்டு. physics and chemistry, okay, you're not able to finish it completely. அதான் நானும் வந்து இந்த மாதிரி பண்ணிட்டுருந்தேன், ஓகே. I was someone who did this exact same mistake, okay. the exact thing, okay. I was doing the exact same mistake. என்னன்னா படிப்பேன், I'll be like 75 to 80% through the chapter and see, this works for board exam. 80% of chapter நீங்கள் படிச்சு you can go and write the exam and still score 100%, okay. board exam it works, but NEET-க்கு it doesn't, okay. எனக்கு என்ன ஆச்சுன்னா when I prepared இந்த மாதிரி அரைக்குறையா and then wrote exam, அந்த நான் ப்ரிப்பேர் பண்ணாதுலேருந்து வரும் கொஷின் கண்டிப்பாக அப்படி தான் கேட்பாங்க, ஓகே. அதுலேருந்து கொஷின்ஸ் வந்துச்சுன்னா ஐ ஒன்ட் பி ஏபிள் டு ஆன்சர். ஸோ திரும்பி அதை எரர் கரெக்ஷன் பண்ணும்போது ஐ ஹேட் டு ஸ்டடி இட் அகேன். அப்படி தான் ஐ ஹேட் டு கொஞ்சம் கொஞ்சமாக கவர் ஆல் தோஸ் அப் அண்ட் தென் நெக்ஸ்ட் சாப்டர்லேருந்து படிக்கும்போது ஒழுங்காக படிக்க ஆரம்பித்தேன் ஃபுல்லாக, ஓகே. ஸோ ஒன்ஸ் யூ ஸ்டார்ட் ப்ராக்டிஸிங் ஸோ மெனி கொஷின்ஸ், ஓகே, than studying, start solving questions and try பண்ணுங்க. முடியலனா then go study. I think that will help at least, okay. Can you tell what's your secret about cracking the NEET, like smart work மாதிரி சொல்லுங்க? There isn't any secret specifically. See, in the exam is not that difficult, okay, with sufficient amount of practice, okay. sufficient amount of practice, repetition இருக்கட்டும், okay. anyone can ace these exams, JEE ஆகட்டும், NEET ஆகட்டும். if சில பேர் pick all these up very easily. ஸோ ஒரு 2 வாட்டி படித்ததுலேயே வந்து they'll be like, okay, they'll be scoring 650 700 அந்த மாதிரி. few people they won't be able to do it. that requires a little bit more effort, little bit more practice. That's the only thing you have to do. If you are not able to get the score which you wanted to get, நீ பண்ண வேண்டிய ஒரே விஷயம் practice or put in more effort than before. That's the only thing. Because it's not that difficult. It doesn't need super high IQ to crack all these exams. It just needs some repetition, some amount of practice, a little bit of understanding. Okay, fine. This is for solving the question, but when you're attending the examination, it requires a little bit of a lot of time management. And நீ எப்படி வந்து டைம் between bio physics and chemistry every time distribute பண்ற, it all depends on a lot of factors. Okay, so there isn't a secret particularly, where you just have to have faith in yourself and put in work. நீ கிடைக்கலனா, I didn't score well initially 11th lana. I used to get 450 and all, but then with sufficient practice and with sufficient repetition, I got decent marks, and then it started to improve progressively. Okay, so the only takeaway is practice. I hope I am clear. Can you say if you crack me? Can you say that if we can crack NEET at this 1 month, knowing the base and doing self? It depends on how you define cracking an exam. Cracking an exam வந்து 50th percentile marks வாங்கி கவுன்சிலிங்க்கு eligible ஆறது is also cracking. Okay, 50th percentile, or getting a decent score to get into a private medical college, or getting a good score for a entry government medical college, or getting a really good score to get into top institutes. Okay, whatever your however you define cracking, it varies. So this is easy, this is very easy. Decent, this is also possible. This and this, it's a little tricky to do in 1 month, but still, if you have faith in yourself and ஓரளவுக்கு நீங்கள் முன்னாடியே கவர் பண்ணியிருந்தீங்கன்னா, it's possible. Okay, so don't lose hope. Because இப்போ 1 month if you're starting, okay, in the last 31 days if you're starting to prepare, just remember there are around 20 lakh people who have already started before you. Okay, people who have already wrote the exam, tried it, didn't failed, and then with a much increased fire in their selves, and they prepare a lot harder. They have been preparing a lot harder recently. Okay, so it depends. So yeah, I hope you understand. And கம்மி வெயிட்டேஜ் சாப்டர்ஸ்லாம் ஸ்கிப் பண்ணலாமான்னு கேட்டிங்கன்னா, யா பண்ணலாம். பிகாஸ் இப்போது மோஷன் இன் ஸ்ட்ரெயிட் லைன் பிளேன்லாம் வந்து இது 2 சாப்டர்லையும் சேர்த்து ஒரு கொஷின் தான் இருக்கும். பட் ரே ஆப்டிக்ஸ் அண்ட் வேவ் ஆப்டிக்ஸில் ஒவ்வொரு சாப்டர்லையும் 3 கொஷின் வரும். அண்ட் தென் மெக்கானிக்ஸாக இருக்கட்டும், லாஸ் ஆஃப் மோஷன், ஒர்க் பவர் எனர்ஜி, சிஸ்டம் ஆஃப் பார்ட்டிகல்ஸ் அண்ட் ஆல் தட், அதுக்கெலாம் வந்து ஹை வெயிட்டேஜ். கரண்ட், எலக்ட்ரிசிட்டி, மேக்னட்டிசம், electricity unit, magnetism unit, எல்லாமே வந்து heavy weightage chapters. Okay, fine. So it is okay to, yeah, it will be useful to practice this 1 month. Okay, but than practicing just questions, question paper solve பண்ணுங்க, like entire 180 questions, and with an OMR sheet where you can shade, and then a timer for 180 minutes. Okay, அப்போ தான் வந்து ஷேடிங் ப்ராக்டிஸ் வரும், டைம் மேனேஜ் பண்ண தெரியும், அண்டர் ப்ரெஷர் யூ வில் பி ஏபிள் டு சால்வ் பெட்டர். ப்ராக்டிஸ் பண்ண. ஓகே, just solving questions and அங்கே போய் appearing on the examination, it won't work. I'm a GP student, and GP ஸ்டூடெண்ட்லேயே இப்போ நிறையா PYQ டஃப் கொஷின்ஸ்லாம் தந்துருக்காங்க. நீங்களும் மெசேஜ் அப்படி தான் தராங்க. இதுக்கு இது பெஸ்ட்டு கடைசி நேரத்தில் என்ன சாப்பிட்றோம். Okay, choose one thing. Okay, choose one thing and stick to it, whether whatever it may be. Okay, because சும்மாலாம் பேப்பர் பண்ணுறது கொஷின் பேப்பர் தரது எல்லாம் வந்து அது சும்மா பண்ண மாட்டாங்க. A lot of thought would have gone into whatever they do. Okay, let it be here or உங்கள் இன்ஸ்டியூட்டில் anywhere. Okay, take one thing and stick to it. Okay, all right, just give me a minute. It was a little too cold. Okay, fine. All right, இதுக்கு மேலே வேறு ஏதாவது queries இருந்துச்சா ask me. இன்னும் 2 minutes I start the class. ஓகே, அப்போ கிளாஸ் ஆரம்பிக்கலாமா? ரே ஆப்டிக்ஸ், பியூட்டிஃபுல் சாப்டர். Still, if you have any doubts, ask me. Okay, இல்லைனா இந்த சாப்டரில் இன்னைக்கு வாட் ஆல் வில் கவர். வில் ஸ்டார்ட் வித் ரிஃப்ளெக்ஷன். ஓகே, பேசிக் ரேஸ்னா என்ன, வாட் டைப்ஸ் ஆஃப் ரேஸ், கன்வர்ஜிங், டைவர்ஜிங், பேரல், அதுக்கப்புறம் ரிஃப்ளெக்ஷன்னா என்ன, ரெஃப். Okay, and then we get into mirrors, spherical mirrors, concave mirror. Suggest an option for physics problem solving. It is hard to predict the type of question. Previous JEE questions நீங்க solve பண்ணி பாருங்க. Previous JEE questions, JEE means. Okay, joint entrance exam, mains. Okay, mains questions 2022 இருந்து 2025 வரைக்கும் all the questions are in the standard of NEET, a little bit higher. ஆனால் நீங்கள் சால்வ் பண்ணால் you'll have a better clarity about the concept. Okay, something I did, it did work for me, so hopefully it does for everyone as well. Because see, basically in 2025 the paper was super difficult. Okay, everybody know it was lengthy. The concepts were a little bit twisted. Okay, எல்லாமே நடந்துச்சு. To have yourself prepared for அந்த மாதிரி paper, you have to solve difficult questions. And difficult questions-க்கு ஒரு நேஷ்னல் சோர்ஸ் வந்து JEE மெயின்ஸ் ஆர் அட்வான்ஸ் அளவுக்கு கேட்க மாட்டாங்க. பட் ஸ்டில் இஃப் யூ ஹேவ் டைம்னா JEE அட்வான்ஸும் ட்ரை பண்ணுங்கள். தட்ஸ் ஆல்சோ நாட் தட் டிஃபிகல்ட் இன் ஃபிசிக்ஸ், கெமிஸ்ட்ரிலாம். ரீசெண்ட் டைம்ஸ் 2023, 2024, 25, 26, 25 வரைக்கும் இட் வாஸ் ஈஸி தான். யா, 24, 25, யா, இட் வாஸ் ஈஸி ஓரளவுக்கு. யூ கேன் சால்வ் வித் a lot of thought. பட் யா, அந்த மாதிரி கொஷின்ஸ் when you solve, your mind, it'll actually open up to a lot of different thoughts while solving any sort of question. இந்த மாதிரி பண்ணலாம், அந்த மாதிரி பண்ணலாம், all those different possibilities அப்போ தான் உங்களுக்கு வரும். ஓகே, நான் பயோ போர்ஷன் முடிச்சிட்டேன், பட் ஃபிசிக்ஸ் கெமிஸ்ட்ரி அவ்வளோ ஸ்டார்ட் பண்ணல. நான் இந்த 30 days செலக்டிவ் சாப்டர்ஸ் படித்தா ஜிஎம்சி போக முடியுமா? ஆனால் யூ குட். ஓகே, ஃபிசிக்ஸில் அதான் சொல்கிறேன், த மேஜர் ஹை வெயிட்டேஜ் இன் ஃபிசிக்ஸ் வந்து உங்கள் மெக்கானிக்ஸ், அதுக்கப்புறம் மெக்கானிக்ஸ் யூனிட்லாம் ஒர்க் பர் எனர்ஜி, லாஸ் ஆஃப் மோஷன் எல்லாமே சேர்ந்து வரும். கரெக்டாக? வாட் எல்ஸ் இஸ் சென்டர் ஆஃப் கிராவிட்டி, சிஸ்டம் ஆஃப் பார்ட்டிகல்ஸ் அண்ட் ரொட்டேஷனல் மோஷன், லாஸ் ஆஃப் மோஷன், ஒர்க் பர் எனர்ஜி, கிராவிடேஷன், இது எல்லாமே வரும் மெக்கானிக்ஸில். திஸ் திங். இதுக்கப்புறம் மாடர்ன் ஃபிசிக்ஸ். ஓகே, இதிலெல்லாம் கொஷின்ஸ்லாம் வந்து கொஞ்சம் டிஃபிகல்ட்டாக இருக்கும். This is easy. Okay, and then you have modern physics, mechanics, and what else? Electricity unit plus magnetism, and then optics full. இதான் உங்கள் மேஜர் ஃபிசிக்ஸோட சிலபஸ். ஓகே, மெக்கானிக்ஸ், மாடர்ன் ஃபிசிக்ஸ், எலக்ட்ரிசிட்டி, மேக்னட்டிசம், ஆப்டிக்ஸ். இதுக்கப்புறம் இஃப் யூ ஹேட் டைம்னா கெட் இன் டு தெர்மோடைனமிக்ஸ், அந்த தெர்மல் ஃபிசிக்ஸ். ஓகே, ஃபைன். ஓகே, ப்ராப்பர்ட்டிஸ் ஆஃப் சாலிட்ஸ் அண்ட் லிக்விடிங் வரும். Properties of liquid, properties of fluids, and properties of solids. Mechanical properties of solids and fluids. Everything comes under mechanics. Okay, fine, pakka. All right. Okay, I think we'll start the class. Ipo. Okay, ray optics. Ray optics and optical instruments. Okay, ray optics la வந்து லைட்டை ஒரு ரேயாக கன்சிடர் பண்ணுறோம். இட்ஸ் அ ஸ்ட்ரெயிட் லைன் மாதிரி கன்சிடர் பண்ணுவோம். அதோட ஃபிசிக்ஸ் இஸ் வாட் we are discussing here. ஓகே, and then wave opticsல லைட்டோட பார்ட்டிகுலேட் நேச்சரோட லைட்டோட வேவ் நேச்சரை போய் டிஸ்கஸ் பண்ணுவோம். ஓகே, ஃபைன். லைட் ஹேஸ் டியூவல் நேச்சர். அதுக்கப்புறம் டியூவல் நேச்சர் ஆஃப் எலக்ட்ரோமேக்னெட்டிக் ரேடியேஷன் ஒன்று வரும். அந்த சாப்டர் ஐல் டேக். ஓகே, ஃபைன். கெமிஸ்ட்ரி ஆனால் ஆர்கானிக் எப்படி மாஸ்டர் பண்ணுறது? ஆர்கானிக் வாட் ஐ டிட் வாஸ் ஐ டிட் என்சிஆர்டி அண்ட் புக் பேக் சால்வ் பண்ணேன் ஆன் மை ஓன். அதுக்கு மேலே ஐ டிடன்ட் டூ எனிதிங். ஐ ஸ்டடிட் ஒன்லி என்சிஆர்டி, வேறு எதுவுமே நான் பண்ணல. ஓகே, அண்ட் தென் ப்ரீவியஸ் எக்வேஷன்ஸ். ஓகே, தே வர் ஹெல்ப்ஃபுல். ஆர்கானிக் பண்ணும்போது யூ ஷுட் ஹாவ் கான்ஃபிடென்ஸ் ஆன் யூர் செல்ஃப் தட் யூ வில் பி ஏபிள் டு டூ இட். எனக்கு அந்த ஸ்டார்டிங்கில் இல்லை. ஐ ஸ்ட்ரகிள்ட் அ லாட், அண்ட் போக போக ஐ காட் த கான்ஃபிடென்ஸ் தட் ஐ வில் பி ஏபிள் டு டூ ஆர்கானிக் கெமிஸ்ட்ரி. ஸோ யா, ஓகே. ரிஃப்ளெக்ஷன். வாட் இஸ் ரிஃப்ளெக்ஷன்? ஒரு ஷைனி சர்ஃபேஸில் ஓகே, வெரி polished surface, when a beam of light hits it, okay, it gets back to the same medium. Okay, fine. This is what reflection is. Correct? Fine. Now this. Okay. Fine. This is what reflection is. Initially, it incident angle on the incident இப்படி ஆகும் on a polished surface, which is represented by this notation. I mean diagrammatically represent பண்ணும்போது. Okay, this is a reflecting surface. The light bounces off of it. Okay, fine. This is basically what reflection is. Idhil the laws of reflection, we'll see what are the laws of reflection. Okay, this is my incident ray. It's coming down. Okay, incident ray normal is nothing but a perpendicular line on the plane. Okay, so incident normal, the angle this is my angle of incidence, incident, and this is my reflected ray, and this is my angle of reflection. Okay, so law of reflection states that my angle of incidence is equal to angle of reflection. Everybody knows this. Okay, எல்லாருமே இந்த எக்ஸ்பெரிமெண்ட் பண்ணி பார்த்துருப்பீங்க வீட்டில் சின்ன வயசில் something. Okay, okay, fine. Next, before, okay, fine. So this is the laws of reflection. Basically இவ்வளோ தான் இருக்கு. And then இதுக்கப்புறம் நீங்கள் போனீங்கன்னா this is the angle between the incident ray and the surface. Okay, this is the angle between the reflected ray and surface. Okay, fine. This is basically what it is all about. All right. Fine. A question for you. Or a light, okay, light ray வருது. It makes it hits a reflecting surface, okay, and makes an angle of pi/3 radians with the reflecting surface, the incident ray. What is the angle of reflection? Okay, fine. You know this is a straight line. Straight line. What is a straight line? Straight line angle என்னது? It's 180 degrees. Pakka? Yes, 180 degrees. Okay, so 180 degrees la, if this is pi/2, okay, normal கூட எடுத்தா என்னது? Where is my normal? Normal எப்படி இருக்குமா? Normal is nothing but 90 degrees. Okay, fine. Perpendicular to the reflecting surface. This is pi/3 radians or 60 degrees சொல்லலாமா? 60 degrees. So then my reflecting angle of incidence will be 30 degrees. My angle of reflection also will be 30 degrees because angle of incidence equals to angle of reflection. Okay, 30 degrees, how will I represent in radians? It's pi/6. Correct? Yeah, pi/6 is the angle of reflection. Okay, pakka. This is a one-shot video. In the video I can't derive those equations in the chapter equations because deriving one of the equation it will take me around 20 minutes. Okay, minimum. In the mari we have so many expressions. Okay, we have simple microscope, we have compound microscope, we have telescope, we have lens makers formula, spherical lenses and then mirrors okay, இதெல்லாமே இருக்கு. So I can't derive everything. And also we have angle of refraction, laws of refraction இருக்கு. Fine, இதெல்லாமே இருக்கு. Okay, the second law of reflection is nothing but my incident ray, normal, and reflected ray all lie on the same plane. Okay, fine. Okay, this is my angle of reflection. What are types of beam of light? There are three type of beams in the chapter பார்ப்போம். These are parallel beams. Okay, they never intersect with each other. Second is divergent beam. Point of first they just move away from each other. Everyone. எல்லாருமே. Third is convergent beam. Okay, this is convergent. These are the three types of beams: parallel, divergent, and convergent. Okay, fine, paka. All right. Object and image. Okay, fine. Object. எல்லாருக்கும் தெரியும் what an object is. இந்த object இருந்து rays they go. Okay, say if I'm having a mirror here. An object is something it's present. Okay, here. Well, an image will be on the other side of the mirror. Okay, it's a reflection of the object. Okay, the reflection of the object. It's a reflection of the object. They are not the same, but still okay. If this is my object, it's the reflection slash image. So okay, fine. This is a plane mirror. Okay, in the mirrors can be spherical as well. They can be curved. Okay, this is my. Usually in this chapter we discuss about two different types of mirrors. This is a concave mirror. This is a convex mirror. Fine. Okay, this is a plane mirror. Okay, fine. இப்போ இந்த image பார்த்தீங்கன்னா whichever forms in a mirror, okay, we cannot be obtained on a screen. Correct? இப்போ you're going to a theater. Okay, the theaterல போய் பார்க்கும்போது you have big projectors. Okay, IMAX இப்போ ப்ராஜெக்ட் ஹெயில் மேரி மூவி வந்துச்சு ரீசெண்டாக. it was good. Okay, after your exam தயவு செஞ்சு போய் பாருங்க. It's really good. Fine. Only after exams. And yeah, இப்போ அதில் தியேட்டரில் அந்த படத்தை போடுறதுக்கு they have projectors. Okay, they have projectors in the back. Okay, they emit a beam of light. Okay, those beam of lights, okay, they converge at a point. Okay, and form an image. Okay, and that image is obtained on a screen. Simple. That's your big screens in theaters. Okay, fine. So anything that's real, it can be obtained on a screen. So a real image is basically something that can be obtained virtual cannot be obtained. Okay, because ஏன்னா real imageல there is actual convergence of beam. Okay, இப்போ நீங்க பார்த்தீங்கன்னா ப்ரொஜெக்டர்லேருந்து லைட் வருது and they actually converge at some point. Okay, virtual imageல they appear to converge at some point, because of which we seem to find an image, but it can't be obtained on a screen. Okay, see this. Okay, a simple representation. light incident, reflected, incident, reflected. Okay, and this reflected rays, if you extend it backwards, okay, fine. You extend it backwards and you find yourself an image which can't be obtained on a screen because there is no actual convergence of rays. Fine. Okay. Now என்னெல்லாம் வேணும் எனக்கு ஒரு image form பண்றது? I need two rays which either converge or they appear to converge. So ரெண்டு ரே வேணும். ரெண்டு ரே they should either converge directly or they or they at least appear to converge. இப்போ இங்க பாத்தீங்கன்னா here they appear to converge, so there is an image formed. Okay, அதே வந்து when you take a projector, yeah, movies again, same example, your super துரந்தர் வந்துச்சு. Okay, அந்த மூவி வந்துச்சு. This is my projector. Okay, lens. Okay, இதுல வந்து they actually converge at the screen. இந்த மாதிரி தான் represent பண்ணுவாங்க. This is the entire path of light. But when you see, for an image to form, there is actually convergence of beam at sides. Okay, இந்த மாதிரி இருக்கும். But this is how it is represented. Okay, there is actual convergence at the point, at every point on the screen. But when projectors are represented, அது வந்து இப்படி தான் represent பண்ணுவாங்க. Okay, fine. But this is not the case. Okay, for image to form here, there should be convergence of two rays. For an image to form here, there should be convergence of two rays. Fine. இந்த மாதிரி தான் இருக்கணும். Okay, fine. So rules for image formation. Will there be space for solving physics in question paper? In NEET question paper la, they gave me 2 sheets of paper in the end. Booklet மாதிரி இருக்கும் question paper. அதில் வந்து 2 sheet வந்து பின்னாடி இருக்கும். அந்த 2 sheetல தான் you have to do everything, entire whatever bio statements நீங்கள் இது correct mark பண்ணுறதோ, chemistry calculation, physics calculation, everything is to be done on that paper. Okay, fine. Okay, let's not drag இதுக்கு மேலே. Okay, fine. இப்போ I have something இந்த மாதிரி ஒரு செட். I have a lens இந்த மாதிரி. Okay, okay. இங்க வந்து I'm having an object. If this is a diagram given, what will be, what is this? Is this an object, a real image, a virtual image? Okay, இது மூணுல எது வரும்? Or a virtual object? Let me know. Real image Hmm? So no one responded. Okay, this is a virtual object. Okay, an object then director rails போகும். Fine, so that's not the case here. Okay, a real image has actual convergence of rays. Okay, fine, அதுவும் இல்ல. Virtual image when you reflect on a தான் வந்து we'll see, but here it's originating, so it's a virtual object. Fine. Okay, a plane mirror, a plane, simple plane mirror. Plane mirror. Okay, very simple. Everybody has a plane mirror in their house. They use it every day. Okay, properties of an image in the plane mirror. என்னன்னா image வந்து whatever you see, இப்போ நான் நேராக நிற்கிறேன்னா, if I'm standing with my legs on the ground and my head in மேலே, the exact image, okay, whatever, however I am, அப்படியே தான் அங்கே reflect ஆகும். Okay, so the image is, it's not inverted, it's erect. Okay, the image is erect. Okay, fine. One. Okay, next. நான் என்ன சைஸில் இருக்கணும் அதே சைஸில் தானே இமேஜ்லேயும் இருக்கும். ஸோ இட் இஸ் ஆஃப் த சேம் சைஸ். Everyone has a plane mirror in the house. If you think any of this is wrong, just go check yourself in the mirror. Okay, you'll figure it out. Okay, there is lateral inversion. My right side will be my left in the mirror. Okay, and my object distance is equal to my image distance. These are the four properties of a plane mirror. I think I'll write it a little bit neater later. And object distance is equal to image distance. Okay, fine. This is basically what it is. Okay, so now deviation, a new concept. இது வந்து 10th நீங்கள் படிச்சிருக்க மாட்டீங்க. Okay, this is a little bit new. So it's so far clear. Whatever, sir, JEE ஸ்டூடெண்ட்ஸும் தான் பார்க்கலாம், இதை பார்க்கலாமா? These questions are on NEET level தான், because கடைசி நேரத்தில் I didn't want to confuse people with a higher topic. But if you want a simple NCERT revision, this will be paka. But JEE konjam pona, my few lectures are at JEE level. Pona EM waves, it was in detailed JEE level, you can watch it. This one, if you want NCERT revision, it's on NCERT level da. Okay, fine, I hope you understand. Okay, so we have incident ray, Okay. All right. So Dr. Dakshin Krishna. Okay. Dr. Dakshin Krishna is preparing for JEE. Okay. Okay. Fine. This is my angle of incident ray, and then it gets reflected. Okay, wow. இது எப்படி போ போகிறதா இருந்துச்சு இந்த ரே. This my ray. இது எப்படி போக வேண்டியதா இருந்துச்சு. It was supposed to go in this. Okay. I think I'll redraw it. Okay, it was supposed to go இப்படி கரெக்டா. But because of a reflecting surface, it had to reflect. It had to bounce back. Okay. So this is my angle of incidence. This is my angle of reflection. Okay. This was the this was the exact path how it was supposed to go. Okay. And this is the path where it went. Suppose இது போனதுக்கும் இது போக வேண்டியதா இருந்ததுக்கும் ஒரு ஆங்கிள் இருக்கும் இல்லையா. This is my angle of deviation. Okay. This is my angle of deviation. Okay. Now angle of deviation எப்படின்னா represent பண்றது. We'll see. This is, if you see ஒரு straight line போது it's 180 degrees. Okay, this is 180 degrees. It's a very simple derivation. So 180 degrees is my the straight line an angle. This entire thing. This is 180 degrees. Correct? Okay. So 180 degrees like you have angle of incidence, angle of reflection, and then angle of deviation. We know that angle of incidence is equal to angle of reflection. So 180 minus 2 into angle of incidence, or minus 2 into angle of reflection is equal to my angle of deviation, represent with this sign. Okay, just D போட்டுக்கலாம். Okay, பக்கா இது வரைக்கும் clear-ஆ? Fine. Fine. Okay, so everyone. Okay, what next? I'll give you a question. Okay. Velocity of object image. So if okay, இப்போ டேரெக்டாக வந்து ஆங்கிள் ஆஃப் ரிஃப்ளெக்ஷன் கொடுக்க மாட்டோம். ஓகேவா? கொஷினை they won't give you angle of reflection or incidence. சும்மா வந்து என்ன போட்டிருப்பானா, if the angle between, just to confuse you all people, okay, if the angle between incident ray and if the angle between incident ray and reflecting surface is say for 30 degrees, what will be the angle of deviation? Very simple. Okay, இப்போ வந்து ரிஃப்ளெக்டிங் சர்ஃபேஸ்க்கும் இன்சிடென்ஸ்க்கும் 30 degrees ஆங்கிள் இருக்குன்னா this is 30 degrees. கரெக்டாக? அப்போனா வாட் வில் பி மை ஆங்கிள் ஆஃப் இன்சிடென்ஸ்? 60 degrees. அப்போது 180 minus 2 into 60 my angle of deviation will be 60 degrees. Correct? Very simple. Fine. Velocity of object in image. Say ஒரு mirror இருக்கு. Okay, ஒரு mirror இருக்கு. In this concept might be a little tricky, but I'll make you understand. Pakkawa? Okay, don't worry. Okay, this is my object, this is my image. Okay, fine. My object is moving with some velocity. Okay, and my image is also moving with some velocity. Kandipa. Okay, kandipa move. Okay, and my mirror is also moving with some velocity. Okay, fine. Mirror is also moving. Object to move. Image move. It's a little complicated. Okay, this is my mirror, my object, and then my image. Fine. இப்போ what you're supposed to do na, get on top of the mirror. இங்கே உட்காந்துக்கோங்க. You're sitting on top of the mirror. Okay, so உனக்கு உன்னோட பெர்ஸ்பெக்டிவ்ல இருந்து the velocity of object with respect to mirror, okay, will be equal to velocity of image. Okay, ஆனால் அதே will be in terms of mirror or relative speed. So it will be it can be, it should be rewritten as velocity of object minus my velocity of mirror, because they're in opposite direction. Okay, so if I take this as positive, okay, fine, will be equal to opposite direction la velocity of image minus velocity of mirror. Okay, because yeah, still they're in opposite direction. Okay, either clear, fine. இப்போ velocity of my object minus velocity of mirror is equal to velocity of image minus velocity of image plus velocity of mirror. So it will be equal to, so my velocity of object plus velocity of image will be equal to 2 times the velocity of mirror. This is the final equation which you are supposed to know. Okay, it's very simple, just remember. Okay, fine. So say my object velocity 1 meter per second range. Okay, this is my object velocity, and say my mirror velocity was 4 meter per second. This was towards the object and towards the mirror. This is towards the object, opposite direction. What will be the velocity of my image? Fine, simple. V object is equal to 1, so 1 plus V image is equal to 2 into minus 4. Because this is in opposite direction, so any one I can take it as positive, so my image will be equal to minus 9 meter per second square. அதாவது 9 meter per second square in this direction. 9 meter per second in this direction. Okay, fine. Clear enough? Thank you. Fine. When you have two inclined plane mirrors, okay, and inclined plane mirrors இருக்கு. Two inclined plane mirrors இருக்கு, and then it's kept it at some angle. Okay, fine, it's kept at some angle, say theta. And இங்கே நான் ஒரு ஆப்ஜெக்ட் இருக்கிறேன், say an apple. இந்த ஆப்பிளோட எத்தனை இமேஜ் will form? Okay, this is my question. இப்போ when I have two plane mirrors opposite வச்சா there will be infinite images formed. நீங்கள் you would have gone to clothing store and see and saw yourself. Okay, அதே இந்த மாதிரி ஆங்கிளில் வச்சுருந்தாங்கன்னா the number of images, okay, if it were if 360 minus divided by theta is even, number of images, okay, n is nothing but, okay, is even. If n is even, number of images is there. If if n is odd, number of images is n. All simple. Okay, and then images, they are formed on a circle. Images are formed, okay, are formed on a circle. Okay, I hope it's clear. Fine. Clear enough. Okay. A photographer, okay, he is standing, uh he's at a distance of 4.5 meters from the mirror. Okay, mirror length, okay, he is at a distance of 4.5 meters. Okay, and an object is at a distance of 3 meters. This is my object, this is my camera. Okay, இப்போ வந்து the photographer is focusing the image. Okay, எவ்வளோ தூரம் தள்ளி அவன் கேமரா லென்ஸை ஃபோக்கஸ் பண்ணால் he'll be able to capture the image. கரெக்டா? It's nothing but 4.5 meters plus 3 meters. That's basically what it is. Okay, so he has to focus the camera lens at to a distance of 7.5 meters so that he will be able to capture the image. Fine. Okay. Done. Okay. What if, so சும்மா numerical solve பண்ண வேணாம். If it was 60 degrees நான் சொல்லுங்க, if 60 degrees was the angle between two plane mirrors, our image form ஆகும். Okay, if it were 50 degrees, they would form 7 images, 6 images. Okay, I mean, if it were 60 degrees, it'll form 7 images. 6, okay, it'll form 5 images. If it were 50 degrees now, it'll form 360 by 50, 7.2, it'll form 7 images. Okay, fine. One more. Before this concave and convex mirror thing, I have one more small concept. Okay, wait. This is all something that people used to skip. Okay. நீங்க பாத்தீங்கன்னா, see, I have an object. Okay, this is my object. This object can be a point object or an enlarged object. This is an enlarged object. In the object ஒரு plane mirrorல நான் capture பண்ணனும்னா ஒரு image இங்க form இருக்கு, full size image of this object form இருக்கு. The size of the mirror required will be h by 2 of the object. Okay, clear. It's simple geometry தான். Simple geometry. Okay, இப்போ பார்த்தீங்கன்னா this is one ray, this is another ray. They are forming an image. Okay, okay. இப்போ இங்க வந்து there is distance. This is object distance. I thought of not deriving stuff, but இந்த மாதிரி சின்ன logical doubts வரக்கூடாதுக்காக I have to do. This is D again. Okay, fine. Object distance equal to image distance. Okay, fine. So இப்போ என்ன பண்ணலாம்னா ஒரு basic trigonometry thing. Very simple. This will also be, this entire length is equal to 2D. 2D. Okay. இந்த theta எடுத்துக்கலாம். Fine. Say this as x is the size of the plane mirror. This x divided by d, nothing but my opposite by hypotenuse, sin theta is equal to height of the image divided by 2d. dd cancel, mirror length is equal to h by 2. Fine. This is the length of the mirror. Paka? Okay, clear. All right. Okay, fine. இதுக்கப்புறம் we'll discuss about concave and convex mirrors. Okay, it's a very simple thing. This you would have studied in your 11th, 10th standard. Okay, it's very simple. I won't have to teach you everything on the basics. Okay, I'll just drink a little bit of water and then we'll start. Okay, how far so far is everything clear, people? The comments. Okay, fine. ஒன்றும் பெருசாக இல்லை கைஸ், இங்கே பாருங்க. It's simply mirror which has spherical in shape. Okay, their reflective properties are a little bit different. Okay, this is a type of mirror. Okay, the pair cycle. Okay, done. This is my convex mirror. பாத்தீங்கன்னா it has a concave reflecting surface, so it's a concave mirror. It has a convex mirror reflecting surface, so it's a convex mirror. அப்புறம் கான்செப்டே முடிச்சு. Okay, fine. This is what basically these two mirrors are. Okay, இவங்களுக்கு வந்து there are when a plane mirror நீங்கள் வைக்கும்போது we discuss a few properties. அதே மாதிரி for a convex and a concave mirror there are few properties. அதை பேஸ் பண்ணி we are using it at various places. இப்போ கான்வெக்ஸ் மிரர் பார்த்தீங்கன்னா ஒரு டைட் ரோட் டர்னிங்ஸ்லாம் வந்து in the corner they would have or a convex mirror thing of a film in a convex shape, so that I could have a wider range of view of whoever is coming on the other side. Okay, நான் பிளைண்ட் ஸ்பாட்லாம் ஒன்றும் தெரியாது. அதே கான்கேவ் மிரர் எடுத்துட்டிங்கன்னா டென்டிஸ்ட்னால் they'll use it to enlarge your teeth. Okay, உள்ள விட்டு they can't have convex mirror which reduces the size of your image. Okay, அது rather concave யூஸ் பண்ணி பக்கத்தில் வச்சா the image will be enlarged, so that they will have proper understanding of whatever the issue is. Okay, fine. So in the mari there are multiple applications of these mirrors. Okay, fine. Before we get into whatever sign convention is, let's discuss about the stuffs, okay, or the notations which you must know. Okay, we have something called as say this is my concave mirror. Okay, this mirror you'll get confused. Let's not do that. Okay, fine. Okay, fine. This is my mirror, convex mirror. Okay, இதுக்கு வந்து it has some curvature. Okay, and the curvature when you extend it becomes a sphere. Okay, so spherical mirror oda ஒரு cut portion தான் வந்து my concave mirror. Okay, fine. Okay, in the imaginary circle oda, okay, center point is called as my radius of curvature. Okay, fine. And this point on the mirror where okay, that's called as pole. Okay, pole எப்படி define பண்ணுவாங்கன்னா, when you keep an object at infinity, light rays converge at a point. Okay, that's called as focus. A point on the sphere which is in the principal axis, அதாவது my radius of curvature and focus சேர்ந்து இருக்கிற ஒரு line, it is on the mirror. Okay, and that point is called as my pole. Okay, this imaginary line is called as my principal axis. Fine. Okay, this okay, now sign convention. How எதெல்லாம் வந்து we'll take it as positive, எதெல்லாம் we'll take it as negative னு பார்ப்போம். Okay, right. This is a little this might be a little confusing, but imagine this. Okay, consider my pole to be in the origin of a graph. It didn't turn out well. Okay, this is the origin of a graph. Okay வா, ஒரு ஆரிஜினில் நீங்கள் பார்த்தீங்கன்னா என்ன இருக்கும், ஆரிஜினில் அதோட coordinates is 0,0. So my pole is at 0,0. Fine. அப்புறம் this will be my positive x-axis, positive y-axis. This will be my positive x-axis. So this will be my negative y-axis. This will be my negative x-axis. So basically coordinate system which we can find out the location. So if I measure height இப்படி, if this is my height measurement na, this height is positive because it's in positive y-axis. Adhe in the height na, this height is in negative y-axis. Okay, this distance of radius of curvature or focus it's this distance. Okay, இது வந்து it's in negative x-axis. அதே வந்து image form வருது வச்சுக்கோ, ஒரு virtual image. If it forms somewhere here, this is my positive x-axis. Okay, fine. So the coordinates which you will be able to easily figure out stuff. Fine. ஒரு concave mirrorல image எப்படிலாம் ஃபார்ம் ஆகுதுன்னு பார்ப்போம். Okay. At infinity, when you keep, everyone knows this. Okay, I don't have to repeat it. This is my concave mirror. I'll try to draw every possible thing. Okay, just give me a minute. I had something here. Just a minute, guys. Okay. I think it's, yeah, fine. Okay. This is my concave mirror. Okay, fine. This is my object. Okay, this is basically whatever happens. Okay, say this is at infinity. Object infinity போக போக நீங்க பாத்தீங்கன்னா the image which is real, okay, because it is because of formation, because of convergence of actual rays. Okay, it is real. Okay, and it goes closer to the focus. Okay, fine. So it forms at focus at infinity, and then எவ்வளோக்கு பக்கத்தில் கொண்டு வரணும், when I am at center of curvature. Center of curvature இருக்கும்போது, அதாவது the radius of curvature, when the image is at the center of the imaginary circle to which the concave mirror belongs to, the size of object and images are same. Fine. Okay, அதே வந்து when you move it further to the focus, okay, the image forms at infinity. Okay, image forms at infinity. Okay, அதுக்கு மேலே if you go between the pole and the focus, okay, the image formed is, okay, the lines inga pathina focus la vecha they form at infinity because of parallel lines. Inga pathina the lines are parallel, but as soon as you take it away from the focus, the lines start to diverge, so they won't even tend to converge at any point. So there is a formation of a virtual image on the other side of the mirror, okay, which is enlarged erect. Okay, so inga varaikkum every other cases it was real inverted actual convergence. Radius of curvature la it was equal to the size of object. அதே இன்னும் focus la vecha it formed at infinity. அதையும் தாண்டி போனா it formed at the other side of the object, I mean other side of the mirror, virtual erect. Okay, this is all it is. Fine. Okay, இதே வந்து concave mirror la பார்க்கலாம். Concave mirror la if object is at infinity, it forms a virtual image at focus. Okay, I'm not able to take it to infinity inga, but still understand. Yeah, you பாத்தீங்கன்னா the more I take it to infinity, the more closer and more smaller the image is. Okay, it's diminished, it's virtual, it's erect, and it's at focus. Okay, fine. When I bring it closer, it just comes back, it comes closer and now. Okay, no matter how close I go, the size of the object is always diminished. Okay, I mean, size of the image is always diminished. It is always virtual, it's always erect. Fine. Okay. This is your convex mirror and concave mirror. I think I finished off a little fast because we have a lot to discuss too. Okay, fine. Okay. Mirror. Okay. Let's just okay. I'll write the thing. It forms virtual and erect and enlarged when it is at between focus and pole. Rest all are real and inverted. Okay, this everyone knows. Fine. So convex mirror, it's the same. It forms virtual, erect, and diminished. அதாவது இங்க பாத்தீங்கன்னா it's always small. Okay, no matter how close you get, the size of the virtual image is always smaller than that of object. Okay, fine. Okay. Okay. Mirror equation. Object distance is denoted by u. இதான் வந்து என்னோட object distance. Image distance and focal length. Okay, fine. இப்போ வந்து mirror equation equates all these three. So my 1 by v plus 1 by u is equal to 1 by f. This is the only thing you need to know. It has a big derivation. I don't have time to explain it before. Just remember this formula. For length, it will be 1 by v minus 1 by u. Okay, fine. Magnification. Magnification நான் சொன்னேன் virtual mean erect enlarged, real inverted diminished, real inverted same size, real inverted enlarged. அந்த மாதிரி I used few terms. The last term was my magnification. The magnification வந்து என்னன்னா basically height of the image by height of the object. So if it was equal, if it were equal to 1, so if my height of the image were equal to height of the object, it wasn't magnified, it wasn't diminished, it was in the same size. Okay, either it was greater than 1, it was magnified a little bit, so that height of the image is more. Are the opposite way? Okay, fine. So it's nothing but my height of the image by height of the object is my magnification. Okay, fine. Which is equal to minus v by u. Okay, fine. இப்போ இந்த சைன் கன்வென்ஷன் மிரர் ஈக்குவேஷனுக்கோட சைன் கன்வென்ஷன் ஃபார் எவ்ரி ஆல்மோஸ்ட் எவ்ரி கேஸ் பார்த்துலாம். ஓகே, ஃபார் அ கான்கேவ் மிரர். ஓகே, இங்கே பார்த்தீங்கன்னா ஆல்வேஸ் தி ஆப்ஜெக்ட் இஸ் ஆன் த லெஃப்ட். ஸோ ஆப்ஜெக்ட் டிஸ்டன்ஸ் இஸ் ஆல்வேஸ் நெகட்டிவ். ஓகே, ஃபோக்கல் லென்த் இஸ் ஆல்சோ ஆன் த லெஃப்ட் ஆன் தி நெகட்டிவ் எக்ஸ் ஆக்சிஸ், ஸோ இட்ஸ் ஆல்வேஸ் நெகட்டிவ். ஃபைன். பட் ஆப்ஜெக்ட் டிஸ்டன்ஸ் பார்த்தீங்கன்னா இங்கே வந்து இங்கே நெகட்டிவில் இருக்குது. ஓகே, இங்கே நெகட்டிவில் இருக்குது. பட் ஆஃப்டர் ஐ கெட் past its focal point, it goes to positive. So object distance in concave mirror ஒரு இடத்துல மட்டும் it's positive, பாக்கி எல்லாமே negative, பாக்கி எல்லாமே negative. Okay, fine. இதே கான்வெக்ஸ் மிரரில் பார்த்தோம்னா ஆப்ஜெக்ட் இஸ் ஆல்வேஸ் நெகட்டிவ். ஆப்ஜெக்ட் எப்பவுமே லெஃப்ட்டில் தான் இருக்கும். ஓகே, த இமேஜ் formed in concave mirror is convex mirror is always on the right, so it's always positive. Correct? It's always positive, it's always negative object distance. The focal length in the convex mirror is always positive. Okay, fine. Writing it down. U is always negative, V is always positive, F is always positive. Okay, இங்க வந்து U is always negative, V can be positive or negative, focal length is always negative. Okay, everything you have learned in your 10th standard, I don't have to repeat it again, but still. Okay, refraction. Okay, this is a very beautiful concept. Okay, whenever light moves from one medium to another, okay, light moves from one medium to another, it does not pass through it, it bends, okay, to some extent. Okay, this bending of light when it moves from one medium to another is called as refraction. Okay, this is my incident ray, this is my refracted ray. Okay, normal varanja, this is my angle of incidence, this is my angle of refraction. Okay, according to Snell's law, of refraction. Okay, very clear, huh? You have 31 days of time. Okay, tell me how to give two number. Study biology and physics important chapters and chemistry important chapters மட்டும் it will be sufficient. Okay, நீங்கள் பயோ மட்டும் ஒழுங்காக போய் படித்து எழுதினாலும் it's okay, fine. Okay, ace and 10th, your 12th is over, 11th கொஞ்சம் தெரியும்னா you still have time, 1 month இருக்கு, don't give up. Okay, ட்ரை பண்ணுங்க, கண்டிப்பாக கிடைக்கும். Fine. Okay, don't lose hope because this exam main it's structured in a way that it deals with it actually affects your confidence in anything. Okay, when you don't get enough score, you will feel so bad that you'll question why are you it goes to on the extent varakum. So okay, so having a strong mind, okay, it's very important for any doctors. Okay, any guy in medical profession, it's very very important. So it kind of trains that as well. So don't give up, don't panic, you still have 31 days of time, give your best. Okay, fine. Where did I stop? I stopped here at Snell's law. What is Snell's law? It states that my sine of angle of incidence divided by sine of angle of refraction is constant, and that equals to the refractive index of the medium. Okay, it can also be said, say if my, or it can also be written as is equal to refractive index of my um, first medium mm, refractive index of my second medium divided by refractive index of my first medium. Okay, if this right which went, it was from air to water, air refractive index is nothing but 1. So air to water pochna, my new one will be 1. This will be equal to 4/3. Okay, but in the case it's not the way. Okay, fine. Angle of incident இருக்கிறது தான் வந்து என்னோட new 1. This is my new 2. It can also be written as speed of light in my second medium divided by speed of light in my first medium. Speed of light in my first medium by speed of light in my second medium. Fine. இப்படி எழுதலாம் c1 by c2. Okay, fine. This c, speed of light, is nothing but frequency into lambda. So lambda 1 into frequency, which is constant, by lambda 2 into frequency of light doesn't change. Note this point, whenever light moves from one medium to the other, okay, the frequency of light, okay, the frequency of light doesn't change. Okay, எவ்வளோ oscillation per second இருக்கோ அதே oscillation தான் அந்த wave it continues, but the wavelength of light it changes. Okay, this deals with ray optics. Okay, ray optics லயும் wavelength இருக்கு. Okay, then just know it is a wave. Okay, fine. Okay, fine. This mu 2 by mu 1 can be written as mu, okay, mu 2 by 1 can be written 2 with respect to 1. Yeah, so can be written as இந்த மாதிரி. Okay, அதாவது refractive index of second one with respect to the first one, or it can also be written as 1 by mu 2 1. Okay, this might be a little confusing. இது வந்து just ஞாபகம் வச்சுக்கோங்க இந்த மாதிரி. This expression can be written as 1 2. 1 2 means 2 by 1. Okay, velocity of boat with respect to water is nothing but velocity of boat minus velocity of water. Okay, BW. But in the case for division, it's the opposite way. It's 1 and 2. Okay, fine. Okay, fine. Okay, now say, now if you have something in the mari, am I clear? Error. Okay, no response. Fine. Fine. If you have new 1 2, another 2 by 1 into new 2 3 into new 3 4, what will be your final answer? So new 1 2 is nothing but 1 2 divided by 1 into 3 divided by 2 into 4 divided by 3. Okay, so 2 2 can cancel, 3 3 can get cancelled. It will be equal to 4 by 1, which is nothing but new 1 4. Okay, this is also important. This is தெரிஞ்சுக்கோங்க. Okay, total internal reflection. Okay, it's a beautiful concept. Fine. Okay, total internal reflection. See, I'm having a light. Okay, there are few conditions for total internal reflection to occur. light has to pass from denser medium to rarer medium. Okay, fine. Only one condition. It has to travel from 1 minute, just a sec. Light has to travel from denser medium to rarer medium. Okay, fine. So I move from denser to rarer. Okay. Initially there will be இந்த மாதிரி ஒரு refraction. Okay. ஒவ்வொரு ஆங்கிளுக்கு சொல்கிறேன். At a particular angle, it will just graze the interface between two medium. ஒரு particular angle of incidence க்கு okay, ஒரு particular angle of incidence க்கு okay, it will graze the interface. Okay va, அதோட refract angle will be equal to 90, angle of refraction. Fine. In the particular angle of incidence is called as my critical angle. So angle of critical angle, I mean incident critical angle, or a sine divided by sine of my refracting angle, which is 90 degrees, sine 90 will be equal to nu medium. Correct? 1 by nu of denser, say nu rarer. Correct? Am I right? Okay. Say if this is air இருக்கும்போது this rarer will be equal to 1. So in the case so my sine c is equal to 1 by nu. Fine. This is a critical angle, and the angle it will go through the interface between those two medium. And the angle தாண்டி, if I increase the angle of incidence by a little more, it will start to reflect. Okay, this will start to reflect. Okay, it will start to reflect. Okay, this is called as my total internal reflection. Idhula the angle of incidence equal to angle of reflection. Okay, this is my total internally reflected ray of light. Okay, here it follows my laws of reflection. Now the angle of incidence is equal to angle of reflection. Fine. Okay, this is my critical angle, the angle at which it grazes through the interface of two media. Fine. All of them simple. Paka, so far clear? Okay. Before getting into spherical lenses, prism and other stuff, let's take a small break. Okay, we have we have spherical lenses, we have prism, apparent depth, real depth based concept, telescope, microscope. We will take a 15-minute break probably. You know, it's 8:20 we will start the class. Okay, fine. See you. Hello, 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 everyone. Hi. Hello. Okay. Um, it's time we start the next topic. Okay. Okay. Fine. Mm-hmm. Right. Hi, Safura. Okay. முடிச்சிடலாம் chapter. It's okay. Hmm. Okay. Hmm. Fine. Now let's get into okay spherical lens and prism. இப்போதைக்கு விட்டுருங்க. What else we have? இதில் don't have anything. Okay. Prism. I'll come back to those in a bit. அதுக்கு முன்னாடி okay. Apparent depth. Okay. Apparent depth. இப்போ பார்த்தீங்கன்னா when you're in a rarer medium, say you're in air, okay, நம்ம ஏரில் இருக்கோம், தண்ணியில் ஒரு ஃபிஷ் பார்க்குறோம், ஓகேவா? there is a fish. I can't draw ஒழுங்கா. I am not very good at drawing, but say this is a fish. Again, this is a fish, okay. And this is a fish. There's a fish inside the water, okay. When I'm observing it, okay, from here, okay, when I'm observing, I find it at a height which is very different from where it is actually, okay. It's somewhere here. இப்போ ஒரு காயின் தண்ணியில் நீங்கள் போட்டிங்கன்னா ஓகே in a tumbler and you put a coin inside, அது வந்து it seems to have risen கொஞ்சமா, கரெக்டாக? Okay, the exact same thing, okay, fine. When you are observing from air, this is the actual position, this is the apparent position. I have a very beautiful question based on this concept. அதுக்கப்புறம் we'll get into spherical lenses, okay. Fine. Okay, now fine. இப்போ இது வந்து this is the apparent, this is the actual depth, h actual, this is the or d depth actual, this is my depth apparent, கரெக்டா? ஓகே, இப்போ இந்த apparent டெப்த்துக்கும் ரியல் டெப்த்துக்கும் ஒரு ரிலேஷன் கண்டுபிடிக்கணும், ஓகேவா? ஃபைன். My h apparent is equal to h actual divided by nu, or my depth apparent is equal to depth actual by nu, okay. So it appears to be closer in the case la. அதே வந்து when this is, so here it is, this is my denser medium and this is my rarer medium, okay. அதே வந்து when it's inversed, okay, when I am in the denser medium and when there's a rarer medium, observe பண்ணும்போது, see when I'm in the water, say I'm a fish and I'm inside water, okay. Okay, ஒரு பறவைங்க இருக்கு, this is say an eagle, okay. The eagle will actually appear, this is the actual height of the eagle. H actual. But apparently it would be somewhere here. The fish would find the eagle. The fish would find the eagle to be somewhere here. Okay. So it will find it here. This is the height apparent. Okay. In the case la height actual into nu is equal to height apparent, where nu is the refractive index of the denser medium. Okay, clear? Right? It's very simple. Fine. Okay. Hmm. Just imagine yourself. So தண்ணிக்குள்ளார we are putting a coin. It seems elevated. அதே வந்து when you're inside water and observing something மேலே, okay, its height is increased by some extent depending upon the refractive index of the medium which you are inside. Okay. At least the second one is not possible. I don't know how many of you have goggles and swim to get into water and do that. But the first one, putting a a coin inside a glass of water is doable. Okay, it seems elevated. Okay, fine. That's a refraction. Okay, fine, done. Now, a beautiful question. Okay, there's a bird. Okay, there's a bird above the surface of water. There's a bird above the surface of water, and there's a fish. The exact same thing. There's a bird and there's a fish. Fish is at a depth of 4 meters. Okay, fine, nice. Okay, the apparent position of the bird and the fish seen by the other are. Okay, fish inga irukku, bird oda position enna kekranga. Fine, they gave me only one value. Okay, bird oda position is 9 meters above the water. Bird is 9 meters above the water, fish is 4 meters under the water. Okay, இப்போ பேர்டோட பெர்ஸ்பெக்டிவ் இருந்து, from the bird perspective, fish will appear closer. Correct? Fish will appear closer. So then the equation goes like h apparent mean 4 meters divided by 4 by 3 is this is the nu of water is equal to my h apparent. Correct? Depth apparent depth. So this is 3 meters. So my bird will find the fish to be 3 meters under the water. அதே வந்து my fish will find the bird to be even higher. Okay, so it is 9 into 4 by 3. அதாவது h actual into nu, this case, which will be equal to my h apparent. Okay, into nu is equal to h apparent. So this will be equal to 12 meters. So 12 meters and 3 meters respectively. Fine, just give me a second. Yeah. Okay, fine. Now one more concept, a concept of lateral displacement. It's very simple. Okay, just see, imagine when you have a cuboidal medium. Okay, or a refractive index, something else other than the medium also. Say this is air, again, this is glass. Okay, it goes through this, it gets refracted and then it goes. This was the path it was supposed to go. Where is the scale? Okay, this was the path it was supposed to go. Okay, This was the path it was supposed to go, this one. It went through this one. Okay, so there's a distance between, there's a displacement of these two. This is called my lateral displacement. Okay, this is my angle of incidence, angle of refraction. This angle of refraction will be equal to the angle of incidence. This will be equal to my in the angle of refraction. Fine. Okay. Okay. Or this can also be called as its emerging ray. So this angle is called as angle of emergence. Fine. Okay. So basically, this is called as this is my lateral displacement. இப்போ இந்த glass lab ஓட thickness வந்து T-ன்னு வச்சுக்கோங்க. Okay, depending upon the thickness, அவ்வளோ displacement இருக்கும். Okay, I am not deriving it here again. It's little complicated. I mean, little time consuming, and I don't have time here. Okay, I'm really sorry. If anyone wants it, I will do it on a different video or ask me in Telegram or something. Okay, Telegram group la kelunga, Instagram, WhatsApp la somewhere. Okay, I'll help it. So this is the del x is the lateral displacement equal to T sine angle of incidence minus angle of refraction divided by sine A by A minus R by cos R. Okay, fine. This is incidence, this is refraction, that is emergence. Okay, this is my or D represent. Okay, this is my lateral displacement. Very simple concept. Fine. Okay, all right. We discussed about apparent height, apparent depth, இது முடிச்சாச்சு. Lateral displacement. Spherical lenses. Okay, we have two types of lenses here usually. Okay, we have a convex biconvex lens and a biconcave lens, a uniconcave lens, a uniconvex lens. அந்த மாதிரிலாம் இருக்கும். This is your biconvex lens basic. Okay, this is similar to your concave mirror. Okay, see the image வந்து எவ்வளோ infinity ட்ட போதோ, I mean object, the closer the image, okay, the closer the image comes to the focus, the yellow dot is focus. Okay, and it's small. Okay, so infinity நான் கொண்டு வந்துட்டே இருக்கேன் பக்கத்தில். Okay, it's coming closer to focusல வரும்போது the image forms at infinity, and then when I come even closer, the virtual image is formed behind the object, enlarged and on the same side of the object. Okay, fine. அவ்வளோதான். The exact opposite thing of whatever a concave mirror was. Almost the anga vande object was in one side and image was also on the same side, real image. Here the real image is on the opposite side. Fine. Okay, now the concave mirror pathikalam. This is same as convex, I mean this is concave lens, same as concave mirror. Okay, focus la irukumbodhu between F and P, wherever it is, it forms a virtual erect diminished image between them. Okay, so it's minus or a thing, or a sign, and when it's at infinity, image is at infinity now, it's a very small virtual diminished image formed closer to the focus. Okay, so basically the same thing of a convex mirror. Okay, but the signs have changed here. Okay, all right, this is your spherical lenses. Okay, there are combinations of lenses which we'll discuss in a bit. Okay, just a minute. So the lenses part is discussed. Okay, the lenses part is discussed. We have few formulas for the lenses. Okay, fine. This is called as the lens maker's formula. The lens maker's formula. இப்போ வந்து that was a biconvex lens with two equal radius of curvature. இங்கே கரெக்டாக the radius of curvature ரெண்டுமே வந்து ஈக்குவலாக இருந்துச்சு. அதே வந்து இந்த ரேடியஸ் ஆஃப் கர்வேச்சர் ஐ கேன் சேஞ்ச் இட். ஒரு பக்கம் ஒரு ரேடியஸ் ஆஃப் கர்வ் வச்சிரும், இன்னொரு பக்கம் இன்னொரு ரேடியஸ் ஆஃப் கர்வ் வச்சிரும், நான் வைக்கலாம். ஓகே, ஐ கேன் டூ தட். ஓகே, அப்படி பண்ணும்போது the focal length won't be the same, won't be the half of the radius of curvature. Okay, so to identify the focal length for such lenses, we use the lens makers formula. அதில் வந்து 1 by f. Okay, 1 by focal length is equal to mu lens by mu medium minus 1 into 1 by r1 minus 1 by r2. Okay, this is nothing but my mu lens by mu medium, and r1 is nothing but இப்போ concave lens எடுத்துட்டீங்கன்னா this is r1, this is r2. அதே convex எடுத்துக்கிட்டிங்கன்னா this is r1 and this is r2. Okay, fine, paka. The side which they finish the circle. Okay, convex the surface தான் இந்த சர்ஃபேஸோட ரேடியஸ் ஆஃப் கர்வேச்சர் தான் வந்து அந்த பக்கம் இருக்கு, அண்ட் இந்த சர்ஃபேஸோட ரேடியஸ் ஆஃப் கர்வேச்சர் தான் வந்து இங்கே இருக்கு. ஓகே, fine. Okay, this is my lens makers formula to find the focal length. I can't derive everything here because every individual derivation takes so much time. Okay, fine. இப்போ வந்து say I have a plano convex mirror, plano convex. அப்போனா ஒரு சைடு வந்து the radius of curvature is infinity, other side it is r2. Okay, so r1 is infinity, so I'll take 1 by r1 is 0 and 1 by r2 is 1 by r2, and then I'll find it here in the body. Okay, this is how we find for different radius of curvature இருக்கிற lenses. Fine, முடிஞ்சு. And then what else we have? And yeah, so relation between image distance, object distance and focal length for lenses. Okay, for lenses it is அங்கே அந்த for your mirrors it was 1 by v plus 1 by u equals 1 by f. Here it is 1 by v minus 1 by u equals 1 by f. Okay, fine. Okay, so இங்கே பார்த்தீங்கன்னா the radius of curvature, I mean the focal length of the mirror's lens depends upon two factors. Okay, one the refractive indices of the medium and the material of the lens. Two, the radius of curvatures of the two sides. So இது ரெண்டுமே நம்ம பார்த்துக்கணும், அதை பேஸ் பண்ணி தான் the refractive indexே இருக்கு. ஓகே, ஃபைன், பக்கா. Now the spherical lenses there might be some questions. Okay, see the sign convention is the same coordinate system வச்சு தான் நம்ம பண்ணோம். sign convention நீங்க பார்த்தீங்கன்னா where is it? Yeah, the exact same system. இதை வந்து we are following for the lenses as well. The coordinate system, positive minus negative x axis and positive negative y axis. Okay, fine. இப்போ if I have combination of two lenses, what will be my approach? What should be my approach? Combination of ரெண்டு lens இருக்கு. Okay, இப்போ இந்த ரெண்டு லென்ஸோட focal length I have to find. Okay, they'll have a focal length. Okay, focal length, அந்த காம்பினேஷன் அந்த focal length ஒரு யூனிஃபை ஒரு lens if we put it. Okay, the net focal length of these, the resultant focal length வந்து ஒரு lensல if we do, what will be it? அதான் வந்து basically the resultant focal length. Okay, it's nothing but simply 1 by f1 plus 1 by f2 is equal to my 1 by f effective. So if this has f1 focal length, this has f2 focal length. Focal length எப்படி எடுப்போம்? For convex mirror, we know the radius of curvature இப்படி எடுப்போம் and the image forms on the opposite side. Okay, so it's positive. அதே வந்து if it was a combination of a concave lens and a convex lens, இதுக்கு வந்து it will be 1 by f1 plus 1 by f2. If this was f1, this is f2. Okay, because convex mirror ku, convex lens ku, the focal length is here, and for convex lens ku, the focal length is on the other side. Okay, fine. Paka, இது வரைக்கும். Hi Anna, how to read chemistry? Charan, how to use your app in laptop? Does it work? Does it work in laptop? Play Store and I think it will work. Okay, do check it out. I haven't tried it in laptop. In a tablet try panna, phone try panna, I didn't try it on laptop. How to read physical chemistry, bro? Physical chemistry, you have concepts which are little difficult to understand in the beginning. எனக்கு it was difficult. Okay, அது வந்து you have to solve numericals. When the logarithm base பண்ணிலாம் வந்து it might be new to a lot of people, but questions வரது வந்து it will be easy. Rihanna, okay, questions will be easy, don't worry, it's very simple. Physical chemistry ku, you have a set of formulas for a chapter, okay, a set of concept for a chapter. அதுலேருந்து physics மாதிரி ரொம்ப twist பண்ணாமல் the questions will be super direct தான். Okay, so practice a lot of questions. Okay, how to read chemistry, the exact same thing. For physical it goes like this. Inorganic, a lot of revision. Make small notes in your paper, in note-ல ஏதாச்சும் சின்ன ஷார்ட் நோட்ஸ் மாதிரி எழுதி வச்சுக்கோங்க. லைக் இப்போ பார்த்தீங்கன்னா when you have a set of properties for a group of elements na, I used to have a graph. Okay, நோட்டில் இருக்கும். I didn't bring the note today. இப்போ this was, say this was 15th group. Okay, அதோட some property, say atomic radii, அது வந்து இப்படி மாற்றி வச்சுக்கோ. It's not accurate. Okay, but still it's not the same. But இந்த மாதிரி ஒரு வேரியேஷன் காட்டுது. And I know the highest radius is for this one, the least is for this one. It has greater than this one, it has greater than compared to this one, compared to this one. இந்த மாதிரி ஒரு comparison basisல there will be questions from inorganic chemistry. So because you don't have all those element reaction equations stuff and all, you have to study all this. Okay, this is for inorganic chemistry. For organic chemistry, NCERT பக்காவா படிச்சு solve questions from previous years. Reaction, conversion reaction 12th NCERT backல இருக்கும். Because it's a continuity from 11th to 12th. Okay, 11th foundation, 12th வந்து கொஞ்சம் advanced இருக்கும். Okay, so you have to study this and this together. And ரெண்டோட conversion reactions எல்லாம் if you practice பண்ண you will have a better understanding. So நீங்களே try to convert one compound to another. Okay, அந்த மாதிரி try பண்ண it will be very very helpful. Okay, fine. So that's for chemistry. Oh, okay, fine. All right, either this is my for a combination of spherical lenses. Okay, where did I stop? We have prism kaduthu we'll discuss the other stuff. Okay, a prism is something which is like this. Okay, it has, this is my angle of prism. Okay, fine, nice. Okay, and then this is, it has, say I'm having a light inside in this angle. Okay, it goes parallel pudi. இது போயிட்டு say it comes out through this way, this in the mari. Okay, this is basically what it is. So this is, I'm drawing two normals here. Okay, fine. This is my angle of incidence, this is my angle of refraction. Angle of refraction, this is my I2, R2. Okay, but when the exact same thing is reversed, I can get the same thing. So அதனால நான் வந்து I'm writing the inside angles as R and the outside angles as I. Okay, I hope you understand. Side R2, I1. Okay, fine. Okay. Fine. Okay. Now this A இருக்கு இல்லையா, this is the angle of prism. Prism is a glass slab with it's இந்த மாதிரி ஸ்ட்ரக்சரில் இருக்கும். It has 3 rectangular sides and 2 triangular sides. Okay, so basically it has 5 sides, 3 triangular, 2 triangular and 3 rectangular. Okay, this is the angle of prism inga. Okay, so basically what is the idea of, I mean, what we are supposed to find in idilana, the angle of prism is equal to R1 plus R2. Okay, R1 is this one, R2 is this is my angle of prism. Okay, ஏன்னா this is my normal. Normal அப்புறம் this will be 90 minus R1. 90 minus R1, this will be 90 minus R2. Okay, fine. அப்போனா this entire thing will be equal to 180 because it's a triangle. Okay, fine. So A plus 90 plus minus R1, A plus 90 minus R2 will be equal to 180. So A will be equal to R1 plus R2. That's a simple derivation. Okay, fine. This, you will be able to do it. So we are applying Snell's law here. Snell's law. Now apply panna sine of I1 by sine of R1 equals to sine I2 by sine R2 is equal to nu. Nu is the refractive index of prism. This is basically what prism is about. Okay, now at a particular angle of incidence, okay, now a particular angle of incidence la, this prism will prism oda I2 will be equal to 90 degrees. Okay, and the angle I'm supposed to find, I'll tell you how this works. Okay, அதுக்கு முன்னாடி I'll draw it again here. Okay, this is my prism. This is angle of angle of prism at a particular angle. Okay, let that be a question for you. I'll take that as a question. Okay, before that, இப்போ the structure பார்த்துட்டிங்கன்னா it's like this. இந்த மாதிரி இங்கே இன்சிடென்ட் அது லைட். Okay, nice. Okay, and then it goes like this. Okay, and then it goes like this. Okay, nice. Fine. Okay, fine. This is my I1 R1, I2 R2. Okay, இப்போ இந்த இன்சிடென்ட் ரே இருக்கு இல்லையா, இதை கொஞ்சம் எக்ஸ்டெண்ட் பண்ணா, okay, it would have gone to some distance, to some place. Okay, அதே வந்து it had been deviated by some angle because of my prism. Okay, and this angle is called as my angle of deviation of prism. Okay, angle of deviation of prism, and this angle of deviation is equal to, okay, இது எப்படி எழுதுறேன்னா, this angle of deviation is equal to I1, okay, plus I2 minus angle of prism. This is my angle of deviation. Okay, so prism it's one formula, 2-3 formulas முடிஞ்சு. Okay, fine. Now say ஒரு particular angle it did total internal reflection here. அப்போ அதாவது my I2 was 90 degrees னு வச்சுக்கோ. At a particular I1, I2 was equal to 90 degrees. Okay, Fine. The angle of prism is equal to 75 degrees. Okay, fine. Medium or refractive index கேட்குறாங்க. Medium or refractive index of the medium கேட்குறாங்க. How will I find it out? Okay, medium or refractive index கொடுக்கலனா how will I find it? Sin A by sin R. I don't have angle of incidence, I don't have angle of refraction as well. Fine. So I can't find it. Okay, medium or refractive index கொடுக்கணும். கொடுத்தா தான் I'll be able to find it. Okay, so let's say medium or refractive index இது sin 3 by 2 1 by root 2. Let's say root 2. Root 2 is the refractive index of my medium. Okay, fine. So ஒரு particular angle of incidence there is total internal reflection on the other side. The angle of prism is 75 degrees. The refractive index of the medium is root 2. Find the, what am I supposed to find? Find the angle of incidence. Okay. Find the angle of incidence. Okay, fine. எப்படி கண்டுபிடிப்பேன்? Sin I2 by sin R2 is equal to nu. Nu is nothing but root 2. Sin R2 is equal to 1 by root 2. So my R2 is equal to 45 degrees. Paka, done. So R2 which my R1 is equal to 30 degrees. Paka. If R1 is 30 degrees na, sin of I1 divided by 1 by 2 is equal to root 2. Sin of I1 is equal to 1 by root 2. I1 is equal to 45 degrees. So the angle of incidence on the first surface is equal to 45 degrees, so that the my I2 was equal to 90 degrees. So it total internal reflection, this is like critical angle. Yeah, this is it just my R, this became my critical angle. Fine. Okay. If you diagrammatically represent it, it will be like இப்படி. Yeah, something like this. Okay, glancing the surface, the two media. It's not working. Okay, fine. This is how it will be. Though my I2, this will be equal to 90 degrees. This is a question. Fine. Paka, clear. Okay. Where என்ன கேட்பாங்க? Depth கேட்பாங்க. Okay, and then you have your optical instruments. You have your simple microscope, compound microscope, and telescope. Okay, fine. Simple microscope is very simple. As the name suggests. Okay, fine. Just give me a minute. Fine. Okay. I think I've discussed almost everything. Everything is done. This is my lens makers formula. This is my relation between these. Okay, I wrote about the Snell's law and all. Okay, effective refractive indices. Okay, apparent depth, real depth. Because this is little confusing. I had to take time for you to understand. The spherical lens எல்லாம் நீங்கள் 10th படிச்சிருப்பீங்க obviously, except lens makers formula and magnification எல்லாம். Okay, simple microscope basically it is a convex lens. இப்போ நீங்கள் பார்த்துருப்பீங்க, நீங்கள் சின்ன வயசில் வச்சுருப்பீங்க ஒரு they call it பூத கண்ணாடி. எப்படி இருக்கும்? It's a convex lens தான். Okay, and what happens, you keep it in between focus. ஓகே, ஃபோக்கஸ்க்கு உள்ளே கொண்டு வரும்போது it will form a enlarged virtual image. Okay, this is my simple microscope. Okay, fine. Okay, simple microscope is on. Okay, magnifying power is nothing but my m is equal to d by f. What is d? What is f? D is the diameter of the lens. The focus is the distance, not diameter of the lens, rather than object distance. Okay, object distance by f is equal to my, I mean image distance by f is equal to my magnification power. And if we then least distance vision, it and the magnification is equal to 1 plus d by f. What is this? Anna, கேட்டிங்கன்னா distinct vision ஒரு least distanceல எப்போ தெரியும், அந்த அந்த கண்டிஷனில் this is the magnification, this is general magnification. Okay, this இது வந்து for least distance. D is nothing but my least distance where I can see it's 25 centimeters. Okay, so 25 centimeters by f plus 1 is equal to my total magnification. Paka. Okay, so if there is a simple magnifying lens, okay, such a way that image is formed at 25 centimeter, and to have 10 times magnification, focal length should be distance closest to vision is 25 centimeters. So 25 divided by f plus 1 is equal to 10 times of magnification. So 25 by 9 will be my answer. Okay, நான் வாயிலே சொல்லி முடிச்சிட்டேன், but I'll still write it again. Okay, so f distinct vision is 25 centimeters. So 25 divided by f 1 is equal to what? இது வந்து 10 times of magnification வரும். This 25 is nothing but my closest point where I can focus proper. Okay, so it's nothing but 25 by 9 equals f. So it will be equal to 2.75 centimeter. Okay, that's my focal length. That's what my focal length is supposed to be, so that I'll have 10 times of magnification when image forms at 25 centimeters. 25 centimeters is the closest vision possible. அதே வந்து தூரமா, if it forms a 50 centimeter na, I should use this formula. Okay, fine. Okay, now let's say I am having a compound microscope. A compound microscope is a little complicated. அதில் வந்து image is super small, I mean object is super small. Okay, and I'm using two lenses. I'm unable to copy it. Okay, I'm having two lenses. Okay, ரெண்டு லென்ஸில் I'm placing it at somewhere, say it's small and it forms at infinity. The object is at infinity. Okay, so from infinity they form at focal length. The rays converge at focal length. Okay, fine, this is my focal. This is f of my objective lens. No, it can't be infinity because this is not a telescope. Okay, this is it's somewhere here. Okay, I'm sorry, this is not this. Okay, but there are two lenses. Objective lens, this is your eyepiece. You'll be seeing it from here now. Objective lens, eyepiece. Okay, where will be your object? Hmm? Just a minute. ஒரே நிமிஷம். Objective, if it's smaller, if objective is smaller, eyepiece is bigger. Okay, it forms at focus between okay, fine. Say the object is here somewhere. Okay, நீ இங்க தான் பார்க்குற. Okay, this is your eyepiece. Object is somewhere here. Okay, it forms a real inverted image. Okay, fine. அப்போனா it's at focus. Okay, say it's at focus. Okay, it forms a real inverted image. இது வந்து என்னோட ஆப்ஜெக்ட், குட்டி ஆப்ஜெக்ட். Fine, this is my small object. It forms a real inverted image. Fine, this is placed in such a way that this real inverted image forms beyond the focus. Okay, this is the focal length of the eyepiece, f of eyepiece. Okay, this is the okay, this is the f of eyepiece. இந்த மாதிரி இருக்கும்போது it will form a virtual erect and enlarged image. It will form something like this. Okay, virtual erect and enlarged image. This image is what we will be able to perceive. Okay, this is what we will be able to perceive. Fine, the concept is simple. Okay, clear? Fine. This this is the height of the object. This is the height of the virtual image, the real image. This is the height of the virtual image. Fine. Pakawa. Okay, so the magnification in this case will be equal to m magnification will be equal to L by f of objective into 1 plus d by f of objective. What is L? L now vande this length, this entire length is my L. Okay, f is f of objective, this is also f of objective, d is the distance of object, okay, from the eyepiece. Okay, this is d. Just remember the formula because I can't really derive it here. Okay, now to our last concept, it's our telescope. Telescope வந்து we have our eyepiece சின்னதாக இருக்கும். In compound microscope our objective lens is small, இதில் வந்து eyepiece is small. Okay, fine. Now they are far away. Stars, planets are far away. Okay, அப்போனா it's an infinity. So infinity வரும்போது they will form at focal length of the objective lens. This is my eyepiece, this is my objective lens. Eyepiece இங்கே வந்து they will form a small tiny image. Correct? They will form a tiny image. These focal lengths are kept in such a way that this thing will be on the focal length of the eyepiece. F eyepiece and f of objective, they coincide. அப்போ என்ன ஆகும், இந்த real image will form another real image which is enlarged and forms at infinity. Okay, fine. So here, this is my magnification here. It's nothing but object height by image height. But using math, simple trigonometry, we can find it out to be focal length of objective by focal length of eyepiece. So, and then focal length of objective is nothing but your v. V is infinity. 1 by v is 0. So 1 by u is equal to 1 by f naught, and 1 by and then f naught will be f of objective will be equal to distance of image, distance of object, distance of v, it will be equal to v. So f naught comes. So v by u. What is u? The image distance. This acts as a virtual object for my eyepiece. So adanala here idu enna kanakna, this will be my image distance and this will be my object distance v, because from infinity 1 by v minus 1 by u is equal to 1 by f naught. U will be equal to 1 by u is equal to 0 because it's infinity. So 1 by, so my v will be equal to 1 f naught. Okay, and then my u is nothing but idha anoda second object. So yeah, f. So this is my magnification of a telescope. This is my telescope. Done. Paka? Clear? Okay. And this, the length of this entire thing, L is equal to f naught plus fe. They always coincide. Okay. Inga vande it's not the case because பக்கத்துல இது வந்து f of eyepiece and f of objective, they don't coincide ஏன்னா the image is not at infinity. Okay, fine. So இதோட length நீ எப்படி கண்டுபிடிப்ப? It depends upon the question. Okay, fine. Very clear. Thanks bro. Okay, fine. Okay, so your microscope and telescopes are over. So all the optical instruments is done. Yeah, thanks a lot. The optical instruments might be little confusing. நானே வந்து கொஞ்சம் இங்க eyepiece and objectiveக்கு தப்பா சொன்னேன் because they are a little, they might be a little confusing, but with கொஞ்சம் practice you will be able to figure it out. L is the distance between those two lenses, and telescope it's simple. Telescope ரெண்டுமே focal length ரெண்டு focal lengthும் coincide ஆகும். The simple microscope is also fine. Compound microscope la தான் you'll find little difficulty because compound microscope la the object is between focus and pole of the first objective lens, and then it forms an image which acts as the object for the eyepiece. Okay, fine. So நம்ம என்ன பண்றோம்னா இந்த கேஸ்ல since it is not virtual, okay, இங்க பாத்தீங்கன்னா this image which forms here, it is a real image, real inverted image. அப்போனா this is beyond its focal length. Okay, this is beyond its focal length. f of objective தாண்டி தான் இருக்கு, so that it forms a real image here, and then eyepiece கூட coincide ஆகுது. f of eyepiece கூட here it's coincide. This is my f of objective, this is my f of eyepiece கூட coincide ஆகுது. அதனால தான் வந்து I'm able to get a enlarged image at infinity. Okay, clear. Fine. இப்போ L எப்படி கண்டுபிடிப்பீங்க? If you ask me, very simple. Okay, you will have this objective இருக்கு இல்லையா, objectiveல இருந்து distance of the object it will be given and focal length of the objective will be given. அதை வச்சு you find this distance. This is the image distance for the objective, image distance of the objective lens. Okay, this plus the focal length of the eyepiece will give you the length, entire length of the microscope. Fine. So V objective plus VFE will give you the length of the microscope, which is L by F naught is the objective or focal length, and 1 plus D by F naught. Yeah, that's all it is. Okay, fine. I hope இது வரைக்கும் clear-ஆ இருக்குன்னு. I think I'll finish the class now. And in Saturday வந்து I'll take ray optics. I mean, this is ray optics. We'll take wave optics. It's a little interesting as well. Okay. So yeah, see you guys anga. Until then, bye bye. See you. Take care. Okay. Bye. If you have any doubts, ask me in the comments. I check it out regularly. நான் அதிலே ஆன்சர் பண்ணுறேன். இல்லை டெலிகிராம் சேனலில் அப்ரோச் பண்ணுங்கள், ஆர் தி இன்ஸ்டாகிராம் account or the WhatsApp number, anything. Okay, fine. Okay, thank you guys.